So let's apply all this kinematics into solving a kind of longer form problem. So this is one from the book. We have a cheetah that's trying to catch a gazelle. And you can read this in the book. We have a cheetah that waits in hiding behind a bush. The cheetah spots a gazelle running past at 10 meters per second. At the instant the gazelle passes the cheetah accelerates from rest at 4 meters per second squared to catch the gazelle. A, how long does it take the cheetah to catch the gazelle? And B, what is the displacement of the gazelle and cheetah? So how do we do this problem? Well, the first step in any kind of problem is to kind of try to draw a picture and visualize what happens. So we've got to draw a picture. So we have a cheetah. So here's my cheetah. And cheetahs are known for having really, really long tails. It's how they keep their balance and can run really, really fast. So this is going to be the initial situation. I have a cheetah. And the cheetah has an initial velocity of 0 because he's not moving. And then he's looking and he sees this gazelle. So here's this nice little gazelle. And the gazelle's really, really skinny. Gazelle has nice, wonderful horns. So there's the gazelle's horns. Looks kind of like a reindeer. We'll give it a big, we'll make it Rudolph, the red-nosed gazelle. And he's running along. And he's got his little tail. And he's jogging along and jogging past. And the gazelle has some initial speed. The gazelle's initial speed is 10 meters per second. So that's the initial situation that we have. And this gazelle, he's going to keep running. And then when he's running along, our cheetah is going to try to run to intersect it. And he's going to have some acceleration that's equal to 4 meters per second squared. And they're going to collide and crash into each other. And I'm going to imagine they're going to have a tea party instead of, they're going to hang out and they're friendly. Gazelle and cheetah. Okay, so we're imagining that these are animals from Zootopia. If you've ever seen that movie, highly recommend it. Go watch that on Disney Plus. Okay, so how do we solve this problem now that we have a picture? Well, we want to start doing some kinematics. And in kinematics, I recommended we make charts. We make tables of everything that we know. So we have two different things that are happening here. We have a cheetah that has some kinematics, and we have a gazelle. They each have different variables that will describe them. So the cheetah is going to run a change in position x. Okay? So he's going to run some distance, we'll call that x, and the gazelle is going to run some distance x. And that distance is going to be the same. So we're imagining the gazelle is traveling some distance right when it starts being intersected by the cheetah. The cheetah has some initial velocity. The cheetah, they tell us, starts from rest. So that initial velocity is 0 meters per second. And the gazelle has some initial velocity. That initial velocity is 10 meters per second. The final velocity. Well, we know the cheetah is accelerating, so his velocity is changing. So we don't know what that is. The gazelle, they tell us no information about its changing velocity, so we can assume it doesn't change. We can assume its final velocity is 10 meters per second. So we're making some progress, doing a good job, writing down everything we want to know. We have accelerations. The acceleration of the cheetah, they tell us, is 4 meters per second squared. The acceleration of the gazelle, we know, is 0 meters per second squared. And we know that because acceleration is a change in velocity divided by a change in time. Change in velocity is final velocity minus initial velocity over the change in time, and our velocities are both the same, so they're 0. And then we have a change in time. The cheetah is running for t seconds, and the gazelle is running for the same amount of time. Change in time for the gazelle is also going to be t seconds. So now what we can do is we can start writing down some equations for each of these. We can write down the kinematic equations and see what we know, see what we can plug in. So let's look at the first kinematic equation. V equals V naught plus A times change in t. I can plug in some stuff. Final velocity, I don't know what the final velocity is for the cheetah. So this equation doesn't help me much. V equals V naught. V naught is 0 plus acceleration, which is 4, times a change in time, which is t. So this is V equals 4 times t. So that's one equation that we can use, one equation that we can write down. It's not very helpful, though. I have two unknowns in this equation. And algebraically, if I have two unknowns, then to solve this, I need two different equations that both have those variables in them. Okay, so I can write down more equations for the cheetah. We've got change in position equals v naught times change in t plus 1/2 a times change in t squared. Now, how does this help us? Well, our v naught goes away because that's 0, and we have our change in x still is equal to 1/2 times the a, which is 4 meters per second squared, times the t squared. Okay, so does this help us? We have change in x equals 2 times change in t squared. Okay, so again, I have two unknowns, so I need at least another equation that has both of those variables in it. And actually, I've now added another variable. I've added change in x. So to solve both of these, I have three unknowns between the two of them. Right? I don't know v, I don't know t, and I don't know x. So that means I need three equations now. Okay, so I need at least one more equation to be able to solve this. Okay, so let's look at the third equation. Third equation, we know vf squared equals v initial squared plus 2 times a times change in x. Vf squared, we don't know what the final velocity of this cheetah is, equals v initial squared. Well, that's 0, plus 2 times a, which is 4 times change in x. Okay, so we do know this. This gave us some information. V squared equals 2 times 4 is 8 times change in x. So I have these three equations. Is there anything that I can do with them, though? Okay, this equation has unknowns of v and x. This equation has unknowns of x and t. This equation has unknowns of v and t. And to be able to solve this, I need the same unknowns in the equations. Here I have v and t, here I have x and t, here I have x and v. I need another equation that either has v and x, that has x and t, or that has v and t. So I can't solve it quite yet. I need to go to the Gazelle. And I can look at the Gazelle, and I can write down all my equations. V equals v naught plus a times change in t. So v final equals 10, equals v initial, which is also 10, plus a times change in t. So I can plug in 0 for my a, that goes away, and I just proved that 10 equals 10. Woohoo. So I need to go to the second equation. Let's see what we got here. Change in x equals v naught times change in t plus 1/2 times a times change in t squared. Well, my a is 0, so that goes away. So I have change in x equals v initial. V initial is 10 times change in t. Hey, this looks good. So this is an equation. I have two unknowns. My two unknowns are x and t. So I can go back to the cheetah and I can look, can I combine this with any of these other equations? My two unknowns here in the first equation were v and t. So I don't want to use this link. I don't want to use these two equations. Okay, let's look at the next one. I have x and t unknown here in the second equation. I also have x and t unknown in the second equation for the cheetah. So these are both the same equation. They both have the same unknowns. So I can use these. So let's use these. I have from the cheetah, change in x equals 2 times t squared. And from the Gazelle, I also know change in x equals 10 times t. These are both equal to x, right? So this is an x and this is an x. So if these x's are the same, then this other side of the equation must be the same. So I know that 2t squared is equal to 10 times t. And now I can do some algebra. I can solve and I can find what the change in time is. So I can divide both sides by 2. That gets rid of the 2 on the left-hand side, and 10 divided by 2 gives me 5. So I have t squared equals 5 times t. I'm trying to get t by itself, so I divide both sides by t. That gets rid of 1t on the left. It gets rid of both t's on the right. So that gives me a t that's equal to 5 seconds. So there we go. I just solved the problem. I found that the time it takes for the cheetah to catch the gazelle is 5 seconds. In part B, what is the displacement of the gazelle and cheetah? Well, I know their displacements are the same, and I have two different equations I could choose. I could choose this first equation, or I could choose this second equation. I'm going to choose this second one, and I'm going to plug in my time. So I have change in x is equal to 10 times t. The change in time was equal to 5, so change in x equals 10 times 5, and that's going to give me 50. So the change in x is going to be 50 meters. Okay. And I could test this, I could check this and make sure this is right. I can plug it into my other change in x equation. So let's go ahead and do that very quickly. So we do a little check. So we have change in x equals 2 times t squared. So change in x is 2 times 5 quantity squared. Change in x is 2, and 5 times 5 is 25. 2 times 25, change in x equals 50. So it all works. Physics isn't broken. We haven't destroyed the universe. Okay? And this is a general procedure that you can follow. I didn't have any idea what I was going to get. I just started writing out all the equations that I know and seeing what would match to let me algebraically solve this.